Good morning all. Guys, in the today's session, we'll try to discuss about the continuation of Dbms SQL commands. So before starting the today's session, guys, we'll try to recall the things of last session. In the previous session of our Dbms SQL commands, we have discussed about how to write queries. There we have written the select query for different problem statements, right? So actually in the last session we took two tables. Let's say for example I'll take you to the Dbms. Okay, MySQL actually I have logged in, and already we know that we discussed how to enter into a database and how to display tables with a select query and all. We started in the yesterday session with respect to the select query. So there we discussed three clauses of select. That means it consists of many clauses. There we have discussed three clauses. One is a select clause, right? The first one is select clause, fine. Then after that from clause. Then after that where clause. These things we discussed, only three clauses. In the select clause we'll write attributes. The purpose of select command is to retrieve a data from a tables, right, from the database, fine. In the select class we'll write the attribute list, right? So which all the attributes actually we have interested, those attribute lists in which we want to print for the user, right? So those attribute names we'll write it in a select class. Then after that in the from class we'll write the table name, where exactly those attributes are present, right? So on which are all the attributes of the tables we have written a condition, those table names, relation names, we'll write it in a from class, right? Then after in the where class we'll write the conditions, right? Most of the time we'll go for retrieving a data by filtering, by applying some conditions, right? To write a condition, an attribute will make use of equal to, less than, greater than equal to, such, not equal to, such kind of operators, right? So such kind of relational operators we can say, fine. Then possibility that sometimes we'll go with writing a multiple conditions in the where class, that we have written in one of the query, could be probably in the last session. That's what retrieve all list of movies which are released in the year 2020, and the movie language of that movie must be Kannada, something like that. There it requires two conditions to be written, and those conditions can be written with the help of that logical operators that we call many and or not, such kind of a thing. So that also, that means we have explored, we took the flavor, we have tasted those things, right? So let us then after that we discussed one more thing in the previous session, how to join two tables, right? There could be possibility that few queries request to retrieve a data from multiple tables. Example, in the last session we discussed how to retrieve a movie details along with the director names, movie names along with the director names, where it requires a movie table and as well as the director table both to be required to retrieve the things, because director name details are present in director table and movie names are present in a movie table, right? So then after that for that we used the foreign keys, that means the attributes, where it acts like a bridge between the two tables. Here as per our example in the movie and the director table, DID, director ID, acts as a foreign key, that means acts as a bridge between these two tables to join, right? So as a join operator, right? So always in the previous session we discussed even this also. When I write a movie table and a director table in the from class, then what happens is, without writing any common attribute joining condition, then what happens? During that time that become a Cartesian product. We discussed Cartesian product in the previous session, right? That means that Cartesian product performs tuple multiplication, right? Suppose if I am having a 3 tuples here and 3 rows here, then the outcome of a Cartesian product that consists of 9 tuples, this connected with these 3 and second connected with these 3 and so on, right? So that we have discussed. That means always a Cartesian product operator on any of the two tables, it generates spurious tuples, that means unwanted tuples, unrelated tuples, right? Those things we have seen. Then it is always required to write a common attribute join condition most of the time, especially when we go with joining of two tables with the help of this common attribute joining condition with equal to, right? So that we have seen, and we have successfully used two tables, how to make use of multiple tables in the from class and how to retrieve it. And there when we are making use of multiple tables to write a query, there we have learned one more wonderful concept of DBMS, guys. What is that? Most of the time writing, because we have seen that especially retrieving a movie details and along with the director name, there we discussed that means we will write a joining condition, movie table DID should be equal to the director table DID. There what happens? Suppose when I write simply DID in the select class to retrieve it, and in the where class DID equal to DID, then SQL compiler is in a confusion state, it is in an ambiguous state. We have seen that ambiguous DID, right? It's an indication that it cannot find out the DID as what we have written either in the select class or in the where class, whether it belongs to movie table or it belongs to a director table. It is in the confusion state, right? So we need to overcome that confusion, right? That ambiguity we need to resolve. To resolve it, there are two ways. Make use of that relation name, that means the table name. From which table you want to take this DID, that means which table of DID you want to print, movie.did, that we can write, reference we can make use, right? And there's a one more way. Most of the time when you go with playing with multiple tables, when we are going with writing a query with multiple tables, during the time we need to join multiple table attributes with the help of this common attribute joining condition. But when I go with writing such conditions, especially making use of a table name, that becomes very costly for us. What the best thing we can do is, better we can go with aliasing, right? This is what a concept we used, aliasing. What that aliasing will do? Take a smaller name or your own identification name, to that make use of that alias name as what you have taken as a reference. Let's say for example movie yam director D, then yam.did equal to d.did. Like that we can retrieve the things. So this is what a beautiful concept, that aliasing, where we can make use, especially when we go with multiple table query where it requires multiple tables. Along with that where we need to write a joining attribute condition with the help of these common attributes, there we'll make use. So let us guys will try to enter into the continuation of this session. Today I am with one more very interesting thing. Let's guys I'll start it with one simple query, that means a problem statement. Let's say guys I want to retrieve the director who is younger in age, that means the most youngest director in the list, that I want to print, guys. How can I print? To print the director who is younger in age, that means who is having a minimum age, such kind of director details, director name, DID, such kind of things, those things I want to display. So which is the table is required to solve this, guys? To solve this, guys, we require only director table. We don't want a movie table, right? Because all director details are present in a director table. Fine. So on which attribute we are concentrating, guys? Anyway, I want to display all director details, so select star we can write. But the age of a director should be minimum in the list, right? So such kind of directors I want to take up. To do that, so what we can write here is, I want to pick the minimum age here, right? To pick a minimum age, there is a minimum one, right? Minimum. We are having some built-in function here. So let me write those built-in functions here. Min, right? Min is an aggregate function. All these functions in DBMS, we call it by name aggregate functions. The first one is minimum, right? So to write to find out a minimum in the list, in the age list, well, what we'll write is select. What I want, guys? I want to pick a minimum age, right? Min of age. From which table? We require director table. Let me write director. Fine. Whether need to write any condition? No. Only this much is enough, Let me write. Let me check whether it works or not. Select min of age from director, right? So let me write. Look at this one, guys. We got a minimum age, but I'm interested about who is that person, person who is the youngest. I got that youngest age, that value, but I want that corresponding name. Can we print it? So let us will check, friends. So select to print a name of a director and director ID. What maximum we can write is write down DID, those two columns, right? DID, then followed by what? D name, the director name, right? This column, that I'll write. Then put semicolon, comma, then minimum of age, enter. We got answer 10 Rajesh 20. So in the same fashion, guys, can I able to get a maximum age? Yes, we can get it with the help of one more function we called by name max, right? Max gives us the maximum value in the specified attribute, right? In the attribute list. Let me take up here as per this data of director table, who is the most elder director? That means a director with maximum age is Suhas, that is 35, right? So can I able to get it? So what things to be written? Simple, replace this min by what? Max, that's it. Let me take up max of age, fine. We got 41, wonderful, There also actually in our table we are having, not Suhas, that is Mahesh, 41, right? So we are getting that value, maximum value in the age list. Let me display that name. I am curious about the name of the director, and with that I want to introduce one more beautiful concept of MySQL, a bug of MySQL we can say, right? How can we overcome that one? We'll take up. I want to display DID, then I want to display D name, director name of maximum age director. What happened, guys? Actually, when we take up select star from director, we are having these three directors, actually 11 Mahesh 41. This is what a director who is having a maximum age, but as per our query we are getting 41. This is okay. What about this one? We got a 41, this is okay, this is okay, right? This is what happened, Then how can we solve this problem? To solve this, that means can we observe in the previous minimum, in a minimum age query, observe guys, we got a minimum age 20, right? And we got 10 corresponding 10 Rajesh, the same value, right? Same 10 Rajesh 20. So in the minimum, could be you may get this kind of a dilemma. Minimum function works properly, maximum function will not work properly in MySQL. No, guys. Even in case of minimum also, the same kind of a error or a bug we are having, right? For example, guys, let us will try to update a Suhas age to 18. Let me write update age, what's the table? Director age equal to something what 18, where DID equal to 12. Set, I missed a keyword set. Let me write. Okay, fine. Query okay, one row affected. Yes, only one row, because DID equal to 12, we are having only one row. Let me see the content. Fine, guys. So Suha's age was updated to 18. Now when I type a query of minimum, when I recall the same query, select minimum age from the director table, when I write the same query, then what is the expected answer? Now it should not display me a 10 Rajesh 20. The expected answer is 12 Suhas 18, right? So let me check what happens. 18 is okay, but what about 10 and Rajesh? This is wrong. Even with respect to maximum age also, look at this one, max age, right? There also, this column, this is okay, but these two things are wrong. Corresponding values, when it is displaying there, it is making a mistake, right? So from this, even with a wrong output also, definitely we can guess something. How exactly it is computing, how exactly it is retrieving a data, right? Can we guess few things, guys? Yes, this is fine, right? The minimum or a maximum calculation is doing fine, right? As part of this data, definitely sure it is working fine, no doubt about it. But look at this one, 10 Rajesh, 10 Rajesh. It's an indication that where exactly 10 and Rajesh are present in the table. In the director table, for both the example, it's giving a same answer, corresponding value is 10 and 10 Rajesh. So on 10 Rajesh, it is present as a first tuple value. Look at this one, guys. It's an indication that it goes to the age column and it picks either the minimum or the maximum value as what we have written. That means based on the aggregate function as what we have used. Depending upon that, it picks that respective value. But it always displays along with this minimum or a maximum age, it always picks the first corresponding tuple, right? It doesn't goes for, even though whether that maximum age present in the 20th tuple, that means 20th row or in the 1000th row, then also it displays only the first row. Suppose if minimum value present in the last row of my table, during the time also it prints only the first row, right? So how can I overcome? Any idea? Sure. We can solve. That means how we can solve this one is half is right, in the answer. Half part of the answer is right. Look at this one, guys. So this is okay, this is accurate, this is what a question. Try to have this value, that means minimum age. With the help of this minimum age, try to pick its corresponding value, right? Can we go with that? Let's say, for example, guys, I may go with this one. I want to find out, for example, with respect to maximum and minimum, in both the cases it's wrong, right? Let me check it with the maximum, right? First one. I am getting select max age from director as per this director table. Select max of age from director. When I write like this kind of a query, then what is the output of this query, guys? Output of this query is, when I write, look at this one, select max of age from director. What's the answer? 41, right? As for this query, we get an answer like 41. Fine. Max age is equal to 41. Fine. This is right. With the help of this, we'll try to pick a person who are all having an age which is equal to maximum age, that is 25. We'll try to retrieve it. So what I want to retrieve actually? I want to retrieve his name and age. Alva? How to retrieve a name and age? Write name, DID, then what? You want to display age. Fine, we'll write it. 1 minute. Let me rewrite the same thing because there's a space problem, right? So select max of age from which table? From director. It gives me an answer of maximum of age, that is 41 as part of this answer, this query, right? We get this as an answer outcome of this. So what we'll do is, anyway I know the maximum age. Now we'll go in search of these persons who are all having an age which is equal to this maximum age, right? We'll try to pick the things, try to get the things, guys. Already we got a maximum age, and try to find a person who is having an age which is equal to this maximum age, right? So like that we'll write a logic. What all things I want to display? I want to display what, guys? DID I want to display D name, and I want to display what? Age. But this age must be what? The maximum age person, right? So that I want to display. So if all displaying attributes to be written in which class, guys? All attributes in which we want to display, all interested attributes, that are always to be written in the select class. So let me go with writing a select class here, right? Select DID D name age. Where exactly it is present? It is in from class, right? So this has to be written in a from class. From which table, guys? Director, right? Fine. Director, we have written. When I write this one, oh, this is one query and this is one query. To pick a maximum, I need to connect these two queries. Now, we need to connect these two because this is separate, this is separate. So now we are having a question. Can we write a multiple select clauses, multiple from clauses? We have written, or we can say this is one part of a query and this is one more part of a query. Now we need to connect these two queries, right, together, right? We need to build one relation. So this displays all directors. Actually only when I write this much, when I execute this kind of a code, what we get is DID, DName, age from a director. That means all director details will be displayed, similar to this, right? All things. But what I want, guys, I want a person where their age should be equal to what? This maximum age. Oh, in the sense, we are having a person whose age should be equal to what? Should be equal to the outcome of this maximum age. So for that, when I write, this is what one part of a query, one query, then we are having a age in the director table, this one, age, right? And this age should be equal to this maximum, the outcome of this query. So this becomes a condition, this equal to, we are checking this, right? So for that, if where I need to write a condition, where we are writing, guys, always the conditions to be written in the where class. So let me write where here, that's it. So where age is equal to this query, that's it. Then how exactly this query will work, guys? This query, whether that outer query works first or inner query works first, that means how exactly things will work. First, it tries to compute that inner query value, that is a maximum age. Yes, this maximum age is ready. Then what it will do is, as part of the outer query, it moves to the first row. What is the first row, guys? 10, Rajesh and 20, right? There we have written always only when condition is true, then only the such tuple, that means in which it is pointing, initially it is pointing to the first row, that tuple will be retrieved. Let me write whether the condition becomes true or not. All condition must be true, right? So already we have executed, the inner query has executed, that is maximum age, it has computed, that is 41. Now the control goes to the first row, that is 10, Rajesh, 20. Their age column, now age holding which one, guys? 20. It checks, is that 20 equal to 41? No, right? So for that, the condition becomes what, guys? False. As part of this example, this is false. So for that, this will not be displayed. Fine. Then automatically control moves to where, guys? It moves to the second row. What is the content of second row? Second row is 11. Sorry. Second row is 11, Mahesh and 41. And it picks the value, age. Age is what? Now it is 41. Don't write semicolon here. 41 equal to what? This maximum age. Fine. 41 equal to 41. So condition becomes true. So for that, this will be executed. That means displayed. Pick it for displaying. Next, it moves to the next row. Don't think that, oh, suddenly it stops. No, control moves further till it reaches to the last row of the current table. Let's say 12, Suhas, 18. The value is 18. Is that 18 is equal to 41? No, condition is false. So for that, what? This will not be displayed. Do we have a further rows here? No, we don't have further rows. Then things will stop. So which is the row which is selected as part of this query, guys? The row which is selected is 11, Mahesh and 41, right? So let me check. So this is what a query. Select maximum age director, where it displays me a maximum age. Then after what we did? What we did is, we made this as one query and we went outside of this query, right? There we have written a one more query. We started again with a select class, Yes, I have written a select class. Then there we have written what, guys? DID, next DName, then what? I want to display age, fine. These three are present where, guys? These three are present in director, from director, fine. Then that itself is enough? No. We have written one more condition. What is that? The age of this director, this age should be equal to what? Director age. Let me write where age should be equal to this minimum age. Fine. Let me write enter. Look at this one, guys. 11 Mahesh, as per this data, 11 Mahesh 41. This is right, Yes, we resolved the bug of MySQL, right? We successfully got that data. In the same fashion, suppose if the question is asked for get a minimum age, can I get it? What changes to be made, guys? Only do a small change. What is that? Instead of max, simply write what? Min age. This is enough, right? Easily I can get the answer. Minimum age and age equal to minimum, right? So this one. So now I am having one question, those who are viewing, so for them, can you pick a person who is having a second highest age or a second minimum age, right? Try to pick an answer, and before watching the next session, try to get solve yourself this one, right? So we'll move on to one more query, that means one more aggregate function. We discussed min and a max, and prior to that I want to add a few more things to it. This is a query. Where exactly we have written? This query we have written as a part of this outer part, right? So all together we are having, actually this is one query and this is a second query, right? This second query we have written as an inner part of this, right? And or we can say it acts like an inner query or a sub query, right? And this we call by name query nesting. We have nesting, that means to an outer query we are supplying an input from an inner query, right? So this kind of queries we call by name nested queries, or we can say query nesting in SQL, right? We are writing, it's a query, this query contains a one more query, right, within this. Such kind of queries we call by name nested queries, right? And this is an outer query and this is an inner query, or we can call by name sub query. This we call by name sub query, right? And this concept we call by name nested queries, right? So like that we can cascade, or we can say we can have a query within a query, query within a query. How we write in a for loop, a loop contains a one more loop, right? Like that, in the same fashion, within that we can write as many things. Even within this also we can write a one more query possible, where the output of the innermost will be supplied to its outermost, right? The output of that query will be supplied to its outermost, right? Like that, it goes on like that. Then let me go with writing a one more query with the help of this table. Can I able to get an average age of all directors? So usually when I go with computing average age, what we'll do, guys, is 18 plus 41, that becomes what, 59, then 59 plus 20, that becomes 79, then 79 divided by 3, like that we'll calculate. Instead of doing all such things, our MySQL gives us one beautiful option, that means one beautiful method, aggregate function, that we call by name AVG. AVG represents average. That's a one more method, we call it by name average aggregate function. From which table? From director table. What I want? Just simply average. Average of what? I should mention an attribute. That means to all aggregate function we must supply attribute of that respective table as an argument, right? So that's it. On which column I want to perform minimum, on which column I want to pick a maximum, or on which attribute I want to perform this average computation, right? So that we have to mention. Fine. Look at this one, guys, 26.33. Even if you add it and divide by 3, we'll get definitely 26.33, right? I'll go with writing one more last query. Later we'll continue in the next session. With the same table, I want to pick the sum of ages of all directors. Can we achieve this one? Sum of age of all directors. For example, I want to sum all these things, or we can say we are having a salary, some kind of an attribute. I want to compute the sum of salaries, right, of all directors. If I want to find out, usually what we'll do, the addition, 20 plus 41, 61, 61 plus 8, 18, 79, right, like this. Instead of performing all such things, suppose if I am having thousands of tuples, then it becomes very difficult for us to perform manually. We need to do. Instead of that, we are having one beautiful aggregate function that we call by name sum. With the help of sum, we can easily achieve this one. Let me write the last query. Select sum of age, right, age from where? From director table. Look at this one. Select sum of age from director. Look at this. We get 79. It performs that addition and it gives me the answer, right? Fine. Can you able to find how many directors are there here? How many directors in the list? We are having 1, 2, 3, 3 directors. I want to count how many rows are there, right? So to perform that, we are having one more method we call by name count. right? Count. It gives me how many rows are there, right? Count of, either you can say how many directors. Each directors are identified based on what? DID, right? Let me write DID. Fine. We are having how much? 3 directors. So 3 it is displaying. That's it. Thank you. In the today's session, we discussed about aggregate function. What are all? Min, max, AVG, sum, and count, right? So min gives minimum of that attribute value column. Maximum gives maximum of the column. AVG gives average of that column. Sum gives sum of that column. Next, the addition result of that specified column. Count gives the how many rows are there, right? That's it. Thank you. Thanks for your patience listening.